Okay, let's look at section 1.5. So there's a couple theorems in here about arcs and angles that we'll go over. First, we want to calculate the measure of the angle, n, let me get a different color, n to h to r. So this angle, and then we're given a lot of information that we don't need. Okay, that's what happens in these problems. We have TF is 17 degrees, arc FH is 30, and we don't actually need those for this problem. What we do need is this arc from H to N is 111. So the theorem that we're using, it's in the book or the notes if you read through it. It's saying if there's an arc of a circle with a tangent line and a chord or a secant line, that the angle that's made actually equals half of the arc made by the secant line and the angle. So if the arc is 111, we take half of that to get the angle measure. So the angle is 1/2 of 111, which is 55.5 degrees. So that angle is 55.5. So remember, just because you're given numbers doesn't mean you have to use them. Okay, which name would best describe P to L? So here's P, here's L. And again, we're given all this stuff that we don't need. Okay, this is just asking for a definition of a line. This line goes through the circle, out both sides. It's a secant. Calculate the measure of the angle GET. So this angle. And let's see if we actually need this stuff that we're given. So GT, this arc, is 15 degrees. Arc T to A is 27, and N to A is 115, and we're trying to find an angle. Oh, and arc I to N is 69. We actually do need that one. So we're using this angle and these two lines, and they make up these arc lengths that we need to use. So we actually don't need this 27 or 115. So I'm going to erase that and just focus in on what's I have in red. So this theorem is, we have an angle. I'm trying to see where I have room to write it. Sorry, I keep moving around. So the angle on the outside of the triangle that's made by two secant lines, the theorem is you take half and then you take the larger arc that's made, so that's the 69 degrees, and you subtract the smaller arc that's made. That's the 15. So for us, we have 1/2, and then the larger arc is 69 degrees minus the smaller arc, which is 15 degrees. And when we calculate that, we're going to get that outside angle from those secant lines. Okay, so 1/2 69 minus 15. So 27 degrees is that angle. That looks like a 270. It should have been 27 degrees. If the measure of arc V to X is 18 degrees, and the measure of Y, so again the outer angle of these two lines, is 29 degrees, calculate the arc R to S. So again, we need to use the two arcs and the outer angle. So I'm going to write it again. The angle is 1/2, and then we take the larger arc minus the smaller arc. But now it's a little different. We know the angle. The angle's 29 degrees. We're trying to find the larger arc. That's what it's asking for. So that's our x. We don't know it. Minus the smaller arc is 18 degrees. So this one requires some solving. Okay, it's not as easy as the last one. So I'm going to do something a little different here. This is 1/2 times both of those, the x and the -18. So I'm just going to start off by getting rid of it. I know you want to distribute it, but in this case you don't have to. So then we're just left with x minus 18. And then 29 divided by 1/2 is the same as dividing by 2. Or not dividing, timesing by 2. So it's actually 29 times 2, which is 58. And then our next step would be to get x by itself. So add 18. X equals 76 degrees. Okay. All right, let triangle XYZ be circumscribed on circle R. So that means it's outside the circle. Let x to s be 4, s to y be 31, and y to z be 65. What is x? Calculate x to z. So this whole thing. So I'm going to fill in some other things we know. Because this is a circle inside a triangle, these lengths are the same. These two lines that come out from S and U, if that's 31, this is 31. If that's 4, this is 4. Guess what else is the same? These two lengths. So because this whole thing is 65, and I know a section, I can find this other section. So 65 minus 31 is 34. That's 34. That's 34. But we want the whole thing, so 4 plus 34 is 38. Same picture, okay? But numbers have changed. X to S is 6. S to Y is 29. Y to Z is 61. If the measure of X to Z to Y, so this angle is 25 degrees, calculate the measure of arc TSU. What's that? All right, so let's see what we have here. We have actually the one we were just using. We're going to take the angle on the outside of a circle, but now our lines are tangent, but it's actually the same equation. We're going to take 1/2, and then we take the larger arc minus the smaller arc. So I'm going to pull up the circle here. I'm going to redraw it. I have a circle. Sorry, it's not a very straight one. And I know that this part around is x. So I want you to think, could I find this value that's left over? What's all the way around a circle? How many degrees? 360. So if I take 360 and subtract this value, then I would get the smaller value. So I know it's not what you want to see, but the large arc is x and the small arc is 360 minus x. And the angle is 25. So we're going to get an equation here. 25, angle equals 1/2. Large arc is x minus, and then I'm going to do parentheses. So maybe you're like, why did she put parentheses around the 360 minus x? And it's because I have to subtract the 360 and the negative x. I have to keep it balanced. It's an equation. So I have x minus 360 plus x minus minus. So now I'm going to combine my like terms. I have two x's and I have a minus 360. Timesing that by 1/2 equals 25. So now we're going to do what we wanted to do earlier, and I told you not to. I'm going to distribute that 1/2 because I'm solving for x. So 1/2 times 2 is 1, or just x. Half of 360 is 180. And then we can add the 180 on both sides to get x by itself. So x equals 205. Okay, that one kind of takes some thinking with the circle. Okay, so remember, when you have two arcs, use the 360. Okay, the measure of arc VX is 16 degrees. And the measure of the angle is 35. Calculate the measure of RS. We have just been doing a lot of these. So it's the angle that equals 1/2 larger arc minus smaller arc. So I'm going to divide both sides by 1/2 to get rid of the fraction. 70 equals x minus 16. Add the 16 to both sides. Oops. X equals 86. This one looks different. Good. Let BF equal 6 and BP equal 11. Calculate the radius of P. Okay, so BP is not the radius. It goes past the circle. But I can make a triangle here. So this goes from the center to the edge of the circle. That's called the radius. And there's lots of them all the way around the circle. But we're going to use this one because it goes to the side and it gives us these other lines that we know. So what just happened, I have a tangent line here. And when the radius of a circle hits a tangent line, it creates a right angle. So what we just did is we created a right triangle where the hypotenuse, the one across from the right angle, is 11. And then one of the legs is 6 and the other leg is the radius. So we're going to use Pythagorean theorem to solve this triangle. Remember, C is always the hypotenuse and then A and B are just the legs. So A, 6 squared plus B squared equals 11 squared. 36 plus B squared equals 121. Now I want to get B by itself. So I'm adding B, so I'm going to subtract 36 from both sides. B squared equals 121 minus 36 is 85. But I don't want B squared, I want B. So I'm going to take the square root of both sides to get rid of that square. So B equals the square root of 85, but we're rounding to 2 decimal places. So I'm actually going to type in the square root of 85, which is 9.22 rounded. This is our last one. So let's see. If the measure of arc ST is 55, calculate the measure of XST. Okay, so did you notice I ignored all of this? I knew I didn't need it because I was finding an angle. Okay, so what we have is we have an angle and then an arc length that starts at that point and then goes this way from a circle. So the arc length is 55, and we're trying to find this angle. So the angle, we've done one similar to this, is 1/2 of the arc length. So 1/2 of 55. $27.5. So this was all stuff we didn't need, and then I just redrew it because that's really hard to see. But when you have an angle that's made from a tangent